The central part of intelligence is in the front of the brain. So that means that when we when evolution created humans, we had to control our environment. And so in order to control our environment, we had to experiment. And in 2014, they discovered that there is a part of the brain that does experimentation. And that experimental part of the brain takes rules and combines them together to create hypotheses. And these hypotheses are tested whether or not they'll work or not. And so the thing is that there's a current hypothesis and there's a backup hypothesis. There's the current testing, and then there's the backup testing for the rest of it. And so the thing is that there's 4 in the right side of the front of the brain, and there's 4 in the left side of the front of the brain. And so the thing is that the number of combinations you can do is proportional to the number of connections between these 4 parts in each side of the front of the brain. And so the thing is that usually if you can hold a certain number of items in your head at once, that will give you the amount of working memory that you have. So usually there's 2 on this side and 2 on this side, and that gives you 4 on average. But usually we can hold 7 numbers or 7 shapes at once in our visual sketchpad or our phenomenological loop. And so because we have about 7 for each one of those, for language, 7 for language and 7 for vision, that is the average. But the reason that is the average is because of the number of connections that go between these 2 parts of the front of the brain. And so the thing is that when you scale the number of connections, that'll tell you how many things you can manipulate in your head at once. Now the thing is that if you have let's say they have 9 items in your head at once, 9 visual items. Now when you're coming up with an experiment, you're combining all those things together. And when you combine them, it's to the power of 2. It's squared. So for example, 9 items squared is 81 combinations at the same time. Now, if you go up to 16 items at the same time, when you square 16, you get 256. And when you have 25 items at the same time, you have 625. And so the thing is that usually the human brain can only do like 9 items at a time. And if you go up to 25 items at a time, or you go up to 16 items at a time, that kind of impossible for certain people. But for people that can do a huge amount of combinations in the front of their head at once, those people are, well, the thing is that an IQ of 180 is about 625 connections in this side or this side. So but that's just the front of the brain. Now to say the thing is that there's also there's the temporal lobe, which has the number of shapes you can remember, and the parietal lobe, which is the number of spatial things you can remember. So the thing is that when we're talking about when we're talking about like for example, algebra is done on the back left side of the brain, and spatial 3D rotation is done on the back right side of the brain, and here is object manipulation is here in the temporal lobe, and language manipulation is in the left temporal lobe. So the thing is that with language, it's recursive, it's nested. So everything is folding into itself, but when it folds into itself, it's like recently the large language models. Everything is going like that. So they're crisscrossing. They're crisscrossing to create new words when it predicts the next word. But with spatial intelligence, it's a little bit different, because with spatial intelligence, you're doing a rotation. And so the thing is that when you have both of the eyes, the eyes are like crisscrossing, and everything is crisscrossing in not one-on-one, where it's two thing like with language it's going like that. But the thing is, it's two surfaces. Two surfaces are crossing each other. Instead of a one-dimensional line crossing with a one-dimensional line, it's two surfaces crisscrossing with each other. And so that creates the spatial intelligence. And so the occipital lobe is where you have details. So the thing is, like, it goes from the front of the brain to the back of the brain in order to generate new combinations of things, to imagine new thoughts, to imagine new possibilities. And so the occipital lobes. So the thing is that, like, I cannot draw things that well. If I were to be able to draw things, my ability to draw things would be an IQ of 80, and that would mean that I'm able to handle about 16 details at once. Now, some people, now when you look at the way people normally draw, they can handle colors, they can handle shapes, they can handle all these details. So so I guess that if I were to estimate the IQ of my occipital lobes, it would be 80, because it can handle 16 details at once. But my spatial intelligence would be 135, because I can handle 256 details at once, I suppose. Because that's what the test said that I was able to do. And so it's just that when you cross things in two planes, when two planes cross each other, that is the amount of detail. So it's sort of like it's cubed. So in 3 dimensions you cube things, and in 3 dimensions you cube things, and in 2 dimensions, like language, you square them. So the thing is that I guess that I guess that what I'm trying to get at is that the front of the brain combines things with the details in the perception, and the perception is the occipital lobe, the temporal lobe, and the parietal lobe. And language does it linearly combine them, and the vision part cubes the details. So the thing is that you take the front of the brain projects into the back of the brain and generates all these new combinations, and then it takes those things and then it says, okay, so now that I have all these combinations and they're all going together, are they going to work in the real world? And that's where the testing part of the brain comes in. And so I guess that if my IQ was 125, then that means that the number of combinations I can handle at the same time is 144. That's how many combinations I can come up with randomly and then see if they work. But the thing is that the Ubermensch would be able to handle about 625 combinations at the same time because the Ubermensch has an IQ of 180. And so it's just that when you think about intelligence, there's this one person that says intelligence cannot be measured. It's not in the brain because we have a soul or something, and so we're not identified with the body, and the brain scanning the brain, and the brain performs no function in intelligence at all or something like that. But he doesn't really know anything about the brain. He's an idiot. So the thing is that what happens is my intelligence level is 125 because I can come up with 144 combinations, and the details of my drawing ability is 80 because I can only handle 16 details at once, and the rest of it is in there because it has spatial details, it has algebraic details, it has symbolic details, and it has word phonetic details. And so if an IQ test was actually measuring something concrete, it would take the network of the entire brain and see what does the front of the brain does and what does the back of the brain does as a total combination of everything that goes together.